Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to do a simple crash course on unsupervised machine learning using scikit-learn. And then later on in the future, we'll try and see how to do the same thing with PyCaret. So before we start, let's do a simple theory, like for some few minutes, then we move on to the practical aspect. So unsupervised machine learning is a type of machine learning, right? And then we all know that we have 4 different types of machine learning. We have supervised machine learning, we have unsupervised machine learning, we have semi-supervised, and then reinforcement learning. So under supervised machine learning, in that case, your data has labels, right? This having a target variable or a class, and then you can have 2 different problems that we can solve with supervised machine learning. Can be a regression problem or a classification problem. So in case an example of a regression problem is trying to predict house price, right? That is simple regression problem. So in that case, you have a continuous target variable. Then you also have classification problem, in which your target variable, your labels or your class are in the format of a category. So trying to predict the class a particular data set or a particular data point belongs to. That is unsupervised. That is supervised learning. Now under unsupervised machine learning, there is no labels. So your target variables have no labels. So you have independent variables and then no dependent variable, right? So there are no labels, and your task is to be able to either label them or find patterns within them. So we can do that by clustering or by association, and then several algorithms. So one of the applications of unsupervised machine learning is customer segmentation, which we'll be trying to see in this tutorial. Now let's see the next one. We can also understand about ML. We have semi-supervised, which combines both of them. Then also have reinforcement learning, which has to do with reward system, agency and a reward system. Now let's move on to unsupervised machine learning, what you'll be doing in this course. So simply put, unsupervised machine learning is whereby you're trying to work with unlabeled data, right? So in that case, your data is not labeled. So a simple example is that we have this text here, we have this data set from here, right, which is countries data set, and then my assignment is that I want to be able to classify all of these countries into their respective continents. I'm classifying, or I'm grouping rather, that is the best term, because this data is not labeled. So I'm grouping all of these countries into their right continent. So in that case, my grouping of all of these countries into their right continent is called clustering, right? So we can do that then using unsupervised machine learning. If I am here and then I start one after that, okay, Andorra, where is it? United Arab Emirates. I know that this is in Asia, this is in Asia. What I'm doing now, I'm using my own manually doing it, right, which is going to take a lot of time, right? There are a lot of countries. I cannot be sitting there and be saying that. So in that case, it is taking time. So I can train the machine to be able to do that for me. So in that case, I'll be using unsupervised machine learning to help me do that. That is the task we're doing, right? So let's start with it. So simply put, for unsupervised machine learning, you are trying to train the system to learn without a teacher, right? So in this case, I'm not the one going to be saying, okay, this is in Asia, this is in Europe. No, there's no teacher. The system is going to identify it and then give me the right labels, the right classes, or the right clusters. That is a basic understanding. So let's check some libraries we'll be doing using pandas in this tutorial, scikit-learn. Then in the future, I'll try and see how to work with PyCaret, then HDBS, right? So there are several ML algorithms that we can use for unsupervised learning. So some of them can be clustering algorithms, can have anomaly detection, can have novelty detection. You can use it for visualizations, you can use it for these ones. So let's check and pick the first one, clustering. So what do we mean by clustering? So clustering is similar to classification, but for classification is for labeled data, right? It's a supervised machine learning approach. But clustering is unsupervised machine learning approach in which your data is not labeled, right? So it's the process of grouping your data set into groups or clusters in such a way that similar data points are in the same group. That is the basic understanding behind clustering, and it's very useful. It's very useful when you're trying to do EDA. So in EDA, when you are using clustering, you are trying to use it to identify anomalies or outliers, right? That is one application of clustering. It can also be used to identify patterns within our data. So this thing that we have, right, there is going to be patterns here that we can identify them using clustering. Again, it can also be used for image analysis or image segmentation. It can be used for search engine, right? In case you're using Bing or search engine, when you upload an image, it's able to identify that particular image or if you have good photos, be able to identify that all of these things belong to this, right? Very nice. We also have customer segmentation, in which or market segmentation, in which you are going to group your customers based on whether they are maybe middle earners, or the frequent buyers or less frequent buyers, or they just come and go, right? Come and do window shop and go. So it's very interesting. It's very useful for customer segmentation and then market segmentation. So there are a lot of things you can do with this. You can even use it to do recommendation systems. So let's start from scratch. So there are different types of clustering. Classification can have flat or hierarchical, or centroid based or density based. But the basic principle behind all the clustering algorithms that is based on distance, right? So the difference between distance, so it can be distance between 2 points, which we have k-means. So k-means mostly is distance between 2 points. Affinity propagating is graph distance. So all of them are distance, but the different type of distance. So like Euclidean distance or graph distance. The mean shift is distance between points. DBSCAN is distance between nearest points, and then Gaussian is different distance. But all of them have to do with distance. So you just have to understand the basic principle is that all of them have to do with distance between the points, right? Okay, so let's see our task. So our task is to classify or group these things into their respective clusters, into their respective continent. So you can get a lot of data sets from here. So this URL, you come back to this place, you can get a lot of data sets here. And then if you look at these data sets that we have from UCI, we can see that they give us the default task. So classification clustering. And the reason most of these things are classification clustering is that when you're able to classify it very well, and then you let someone supervise over the clusters, you can be able to use the same data that you have clustered, right, to be able to do classification. That's right. So that's why sometimes it's similar, but they are different. Okay, so let's start with it. So let's start with using k-means, right, algorithm to help us with our task. So our task, as we know, is that we want to be able to group these countries into their right continent. So k-means can be useful for that because it is fast and scalable, but the demerit is that you need to know the number of clusters that you need to group them. So the k is the number of clusters. You need to know them to help you. But there are several ways you can fix that, which you'll be learning later on. Either use the elbow method or hierarchical method. And then in case there are varying size and different densities, it may also affect your performance. So you have to scale them. So let's start with it. So let's start. So our task. So we are getting a data set from this place, which is here. So I'll copy this one here. Right. So I have to do this. Copy the entire stuff like this to the end of the page. We are doing everything from scratch. So let me copy them. Right, so I'll copy this one. I need to copy this. Right. We can write a script to do that, but let's copy it in a simple way. So I'll open here, right, which is this one here that I've pasted. Right. So we have it here. So the same thing here. The same thing that I copied from here is what I've pasted here. Right. Very interesting. So I'll save it. Right, I'll save it and then let's check it. Let's see. So some of them, you see that these are all tab separated, right? From here there was no, it's like a table, but it's not proper table because I just copied and pasted. So let's save it and read it. So I'll save it here. So let's save it here, and then let's copy it and then work on it. Right. So be important pandas. Be important our EDA packages. So be important pandas as NumPy, pandas and a NumPy, and important our visualization packages, which I've already done. And now let's start from scratch. So I'll be loading my data set. So let's load the data set. Remember that I'm doing everything from scratch. So dfpd.read underscore csv. Then I'll pass in my country. This one, country geodata, right? The one we copied from here, right? If I read it, it has read it, right? But you see how it's going to be. So df.head. This is not the best format, right? So, and you can see that there's a \t here, right? So that means that it's tab separated, right? So you have to make sure that you read it like that. So let's come back here, and then let's read it with this separator. So just come back here, \sep, then \t, which is the same thing here, tab separated. So if I read it again, going to read it perfectly. Then if I go back, now it's reading it perfectly for us, right? It says it has been able to read our dataset in a very nice format for us. So I can actually save this one as CSV. So let's save it straight away to CSV. So let's save it to CSV, to df.to CSV, and we can call it as countries data.csv, right? Something like that, so that we can use it later in the future. Now let's analyze this data simply, then we move on to see how to cluster them. So if I go back to what we have done, what we have so far, and I go with df.head, now everything is working as expected. I can check for the data types, which is going to be df, there's going to be check for d types, so df.d types, and then from here we can see that we have float, and object. So the name is object, the country is object. It makes sense. Now let's check for missing values. So check for missing na, n is going to be df.is no dot sum, and if I check for it, there are some missing values there, right? So we have to remove them. So let's remove them out. So removing those missing values, because that means that, and if you look at it, there is one country, one latitude, all of them, these are missing. That means that there's nothing there at all, right? So we can just take it off. So it's going to drop na, it's going to be df.drop na, right? You're going to be dropping the na, then we will just put it back as this. So now if I go back and I check it again, let's copy this one here and recheck it. Perfect. So if it is clean, right? Perfect. Now the next thing we are going to do is let's check for the column consistency. So df.columns. So the columns are consistent, they are all in lowercase, so it's going to be easy for us to do whatever we want to do. And then let's check for the shape of our data set. How many countries do we have there, right? How many countries do we even have in the world? So going to be check for countries, going to be df.shape. If I go with the shape, this is going to give us an error because it's supposed to be shape, because shape is an attribute. So we have 243 countries in the world, right? So we're trying to see how to group all these 243 countries into their respective continent. So that is the basic understanding behind that. Now let's see some simple stuff we can do. Let's try and see whether we're able to plot this thing, right? Do a simple plot of our countries. So we'll be using the latitude and the longitude to help us do our plot. So in that case, it can be like this: plt.scat_cutter. Then I'll just go df.latitude first, or we can just go first of all with longitude. Longitude first, longitude, always longitude first, then latitude. So df latitude, right? So something simple. So if I go with this particular plot and let's plot it out. So perfect. So it has been able to plot it perfectly for us. And if you can see this, it looks like this. Please look like a little bit like Africa, but we'll be working on it later on to see it very clearly. So that is a simple plot. We have this is a scatter plot, right? So how do we know them? How do we group them, right? So this plot that I've done, we can see that some of them are grouped at a particular place, others are grouped at a far away place, right? And all of these things are the countries, and that's how they actually are. So we'll be trying to see how to use KMeans to group them very well and then see their plots in a nice way. So let's check it out. So I'll come back, take off this, and then let's start working with KMeans. So KMeans, as we learned earlier on, the K stands for the number of clusters that we want to do. We are using a distance. We will be comparing the distance between the points to be able to find their clusters, right? So there's going to be a centroid, a central point, then they are trying to find the distance around them, right? That's the basic understanding behind it. So in that case, we will just be importing, so it's going to be from scikit-learn.cluster import KMeans, right? That is all that we need. Perfect. Now let's first of all, by knowledge, we already know that we have 7 continents. No, is it 7? 6 continents, right? North America, South America, Europe, Africa, Asia, Australia, and Antarctica. So it's like 7 continents. So by default, we know that we have 7 continents because this one looks like somewhere far away. So because we know this by assumption, as I said, that's one of the problems with K-means. You're supposed to actually you have to define your K, right, to make it well, but we can figure it out. So by assumption, we know that we have 7 continents, right? Although Antarctica is a wall continent, right? You have 7 continents, so we'll be using K as 7. So that means that K is going to be 7, right? Something simple. Now let's work on it and build a simple model. So I'm going to call it as my KM for the K-means. Then I'm going to be my K-means. Then it's going to take the number of clusters. Going to 7, right? So the reason it's giving us this error is that I imported K-means here, supposed to be capital. Perfect. That is a basic understanding, right? Now we need to be able to prepare our data. So we're going to prep our data. So in most cases, when you are working with K-means, you're supposed to scale your data, but because it's a longitude and latitude, there's no point scaling them, right? So let's prep it and let's build out only our features. So we can just call that my S features, which is going to be, we are using the longitude and the latitude to help us with that, right, for our features. So it's going to be this option. We have our longitude, right? Always longitude first, and then our latitude, latitude, right? That is the basic stuff you're using. Hopefully there's no mistake in the spelling. There, we made a mistake here. Perfect. So we are done with that. Now let's fit and predict our data. So we'll be trying to fit our data with our model, and then we're going to build a relationship between them, identify the patterns, and give us our result. So this is going to be fitting and then predict, right? So let's go straight away. It's going to be km.fit predict. Now passing my S features. So I can actually put all of these things into my clusters, right? So I'm going to analyze it. Perfect. So now, so there are some things we can do with this stuff. So first of all, we can just get all the labels, or in this case, all our clusters, right? If it was classification to be called classes, right? But in this case, all our clusters by going with my model. So km dot, that's what the model that I have, dot labels underscore. If I go with this, it's going to list all of them perfectly for us, right? So these are the different clusters within our data set. This same thing is the same thing that it predicted. Yeah, so it's the same thing here. So if I go back to my clusters, it's the same thing, right? Perfect. So we can actually compare if the clusters that we stored in this variable is the same as our labels. So in that case, it can be something like this. So let's come back here and let's check, right? So we'll be checking if our prediction or predicted clusters is the same as our labels, right? So in that case, it's going to be like this option. So I can just go with my clusters in my, I can just make it like this, KM labels. No, I made a mistake somewhere. Let's fix it. It's supposed to be here. True, right? So it's the same thing. That is why they are there. So it's very interesting. So let's see how to map them. So we'll be mapping them perfectly to us. So that is something simple that we have done. Right. So they are there. So this is one way of doing it. I can also make it like, is my clusters the same as this? So we can make it in. That means they're going to check if they are there. True. But the best way is just go with S, right? Perfect. You can also check for all the clusters or the centroid. So the centroid is a point that you're going to be used to group them, right? So or the center, simply so similar, right? So you can just do the same thing. So km dot cluster, we have clusters center, right? It's also going to give us, so these are the coordinates, right, that will be centered around them. And if you look at this, they are actually 7. 1 2 3 4 5 6 7, right? So these are the clusters, the main clusters that are going to the main clusters for each and every of the continent that we have, right? So it's going to center them around these particular clusters or centroid. Very interesting. Cluster center point or centroid. So let's store our predicted clusters into a variable. So it's going to be like this. It's going to store and map. So it's going to be something like this. So df, we call this one as my cluster of continents, right? Then I'm just going to go with my clusters. Perfect. So now I can actually preview it. So df.head, and now we can see that we have this country, the latitude, longitude, the name, and then the cluster. And if you look at this now, we realize that United Arab Emirates, right, which everybody knows is in Asia, is in the same place with Afghanistan. Everybody knows that Afghanistan is in Asia. So with this KMeans, with this unsupervised machine learning algorithm, you've been able to simply classify these things in their right places, right? That is very, very interesting because it's using the latitude and longitude. Now let's plot these ones out, right? So we'll be plotting them out. So let's see a simple plot of it. So let's do a simple plot of our clusters. So we're doing the same thing that we did again. So in this case, it's going to be my plt.scatter. Here's the scatter plot. Now passing my value. So I'll be passing the same value that we had here, right? So in this case, it is going to be my df. Then I'm passing my longitude first, longitude, and the next one is going to be my latitude. I don't know whether you can see it very well, right? Then I'm going to give it my c. The c, I'm going to give it my clusters for the continents. It's going to be this option. Going to be df, right? My cluster for the continent. Right now, I can just give it my C map of, let's use rainbow. So rainbow to give different colors. So that is something simple that we have built. Now I can actually go straight away with this. Let's plot it out and see. Voila. So this has been able to cluster it very well. I don't know whether I can see it very well. Just clustered in a very nice and simple way. But then what I want us to do is that I want us to be able to map these ones, right, with an actual map of the world, right, so that you see where all of them belongs to. So we'll be trying to do that in this session. So we can see that all the locations that are in this purple one belong to one particular continent. So possibly this may be South America, this may be North America, this may be Europe, this may be Africa-ish, Asia, and even in Asia there are different locations, right, different colors, right? So let's see how to map them. So our assignment now is to map this one with our normal world continents. So we'll be using Geopandas to help us with that. So what we'll be doing that we'll be trying to map our scatter plot over world map, right? So using Geopandas to help us with that. So it's going to be import Geopandas as PD. You can use volume if you want. Then we going from sharply dot geometry import point, and then polygon. That's in case you'll be using that one, right? Then just go to import this cartes. Going to import them perfectly. Hopefully it doesn't give us any error. Perfect. Now let's first of all create our world map. So this is going to be our world map. So by default we can get all of these things from Geopandas. So it's going to be my world, which in this case is going to be my GPD. See what I made? We made a mistake here, which we should correct. Otherwise it's going to affect our work. So GPD, right, not GD. So GPD dot read file. Then I'll pass in my stuff, right? So I'll just get it from Geopandas.dataset dot get my path. Then I'll pass in the natural earth resolution, low resolution. That is also, this is going to help us get that particular map, right? So we are reading this particular inside our dataset file here. We have this particular resolution, natural earth. Then I'll just equate it to ax then world dot plot my figure size. So let's set the figure size to be, let's say 2010, right? And now from here we can actually plot it. So let's go with as is is equal to axis.axis. Let's set this off. We don't want to see the axis. So this is going to plot it perfectly for us. It's giving us an arrow, named arrow. So GDP. GPT, not GDP. It's going to plot in a very nice format for us. Perfect. So this is our world map, right? So we want to overlay this on top of this, right? Of course, we are going to scale this one. So let's see how to do that. So it's going to be very simple. So overlay, overlap our clusters on this one. So how do you do that? First of all, let's convert our data set into Geopandas before. So let's call this mine G, right, 01. Then I can just go straight away with my GPD, Geopandas.geo data frame. I pass in my data set. Then from here, I'll just pass in my geometry. Geometry is go to Geopandas dot right. Then I just go with points from SY. This is one of the methods. Then I'll pass in the point that I want to convert into geometrical point or coordinates, right? So in that case, it's going to be my longitude first, longitude, and the next one is going to be latitude. So df latitude, right? That is what I need. So if I go with this, it's going to convert them perfectly for us. So if I go back with my J01, perfect. So you see that we have our countries, our latitude, longitude, we have our name, the clusters, and then we have our geometry, right? These are the coordinates, these are the points that should be plotted on Geopandas, right? So let's see how to do a simple plot on it. So it's going to be something very simple. So I just come back to the same thing with my figure, then an analysis. Then I'm just going to plot. We are using subplot, so today you're not going to make that mistake. Subplots. And then from here I just go with my figure size. So figure size. Then let's use it as 2010. That is all, right? That is the basic stuff. Perfect. Then from here I'm just going to put my J01 plot. I'm going to plot. Let's go CMap. So in this case we are using rainbow, just as we did above. That's all. Then I have to set the axis so that it maps the axis as expected. Then I can now come back to this place and go with my boundary. So world dot geometry dot boundary. So in this place, right, in this one that we did, we use a color, right? But we don't want to get these blue colors. We just want to just use a boundary, right, without the color. We can also do that, but we don't want to bring the color. We want to just get the boundaries. That's why we're going with this option of dot boundary, right? Then I'll just go with dot plot. I pass in the color, so the color is going to be none. And I need to set an edge color, so that is going to be my edge color. So let's give it as K. Then we can also specify the line with the line for the boundary, which is going to be 2. Then it's passing the others going to be others, right? That is all that we need. So let's hopefully everything is working as expected. There's not going to be any error. Voila, right? So now you can see that now it has overlapped this our scatter plot that we did here, right? This thing that we did here, we can also make it bigger in case. So let me copy this one. Let's bring it down and compare it. So this is it. This is the scatter plot, right, that we had, and it overlapped on our Geopandas, right? So we can actually see that they are actually in the right places. So all the scatter plots that we had here, the one that it was clustered well based on the particular cluster, right? So I've copied it and pasted it here, right? So the same thing that we have above here, the same thing that we have above here is the same thing that we are getting here, right? So it's almost the same, but this is what we got, right? Very interesting. It's scaled up well, and it's the same thing that has been overlapped here, and then it actually even look like the same continent. You can even see that, I don't know, you can see the colors here, right? This place look like Africa-ish. This looks like South America, North America. Which is almost the same thing that you are seeing here, right? Very interesting. So with this particular method of machine learning, unsupervised machine learning using KMeans, we have been able to do our task of finding where each and every of these countries belong to, right? That is how to work with KMeans clustering, to use it to help you label or cluster, right, data, right? Something very simple, something very cool. Now let's see how to actually group them well. So to recap, the basic idea is that you just need to get your data, right? Then you, by assumption, we know that we have 7 continents. That's why we had a key of 7. Then you pass in your data, your values, then you fit and predict it. Then now you can actually see your prediction. These are going to be our centroid or our cluster centers. So let's go back to what you have done so far and now name it variable. So we can now change these ones. So df.head, we can now change these ones that we have, right, into their respective ones. So we already know that this is Africa, this is Asia, this is Europe, this is America, this is North and South America, this is Antarctica, this is Australia. So we can actually use that same thing to help us group them. So in that case, it can be something like this. You can just come back to this place and then change these mappings, right? Change these mappings to the right continent. So I can just come back here and then let's do something like this. Let's call this continent map or continent dictionary, which is going to be a simple dictionary. So the dictionary is going to be, if it is North America, right, then I'll give it that particular number. So how do I identify that? So we can actually use the same thing, this option. We can use the plot we did to know, right? I need the plot to know. So we can also use the same thing. So in that case, it can be something like this. I can just come back here, then go with my df, then I'll just pass in the particular cluster that I want. So cluster continent, I don't know whether everybody can see it all. Cluster continent is equal to 1. This one is 6, right? So if I put 6, or let's use this one as, let's put this one as Afghanistan, or let's change this one to, see what I'm going to do. Okay, so let's use something like 6 here. This is Austria, right? We know that Austria is in Europe, right? Yeah, I think Austria is in Europe. Armenia is, wow, Albania is also in Europe, right? Very interesting. And then we also have, what's the name, Bosnia, right? So very interesting, very cool. We have Australia is 5, and we already know that Australia is in Australia. We have Aruba is 0, right? And then this thing can help us do some interesting stuff. So I can just come back and check for, let's say, number 1. If I go with number 1, df, you can actually get all countries that are there. So by this, Bangladesh, Brunei, China. Oh, everybody knows that China is in Asia. So that means that number 1 is going to be China. It's going to be Asia. So you can just go with this, Asia. This is going to be number 1, right? Very interesting. So you see how we are doing it. I can also change the same thing from here to, let's say, 2. Number 2, we know that number 2 is United Arab Emirates, which in this case we have something like Afghanistan, which is also in Asia. Armenia, which is in America, is in Europe. Azerbaijan is in Asia. So because Asia is very big, if you look at our plots here, right, you can see that this was mostly South America, but for Asia they had 3 different clusters, 1, 2, 3. So that means that we can actually try a different classification of for the continent, not just using the 7 continents, but you can actually name them, right, based on, let's say North, South America, maybe Eastern Europe, Western Europe, Sub-Saharan African. You can also say Middle East, right, like that. You can say Far East, Australasia, right? So you can actually use, from this thing I have seen, you can actually have more names for that, right? Very interesting and very cool. That is how to do the same thing. So actually, after doing that, we can actually map them later on as we are doing. So that's going to be an assignment for us, right, for us to do, because we are getting an issue here. But that is the basic understanding behind that, because we are using KMeans. But I'm sure if you use a different algorithm, it will be able to give us a better clusters, right? Very interesting. So that is something nice. So this one is Asia, Europe, so we can call this one as Cyprus, Ethiopia. Some of them are funny anyway. Some of the clustering are funny anyway. What will you do? Okay, so let's check for 3. We know 3. We don't know what these places are. I mean, I don't know any of these things. I don't know them. Then let's try another one for 4. Okay, perfect. So we have for Angola, Antarctica, Burkina Faso. These ones I know. These countries I know because they are in Africa. So I can just go with Africa, which is going to be number 4, right? Because Africa is big. And then let's check number 5. Okay, these ones, so I don't know. New Zealand, New Papua, these ones are in Australasia. So that means that number 5 is Australasia. So Australia, it's a continent. Australasia, right? No, Australasia. Okay, so let's call that one as 5. Then let's check number 6. So number 6, Albania, Senegal, Tunisia, Ukraine. Okay, so this Kosovo, these ones are like Eastern Europe, because Ukraine, Vatican City, they are mostly like Europe. Yeah, these are Europe. So you can just call them as Europe. So number 6 was Europe. So that's going to be Europe. You can call it Europe 2, right? Which is going to be number 6. So we have 1, 4, 5, 6. Then let's check for the last one, which was 0. So 0 was, I don't know any of these countries. Argentina, Aruba. Okay, this is North South America. Okay, wow. Which is going to be 0, right? So now we know that 0 is South America. Then hopefully 1. So what is left? Number 2 will be Asia 2. Number 3. So the issue we are having here is that this one's number 2 is giving us a lot of almost every country. So we have some in Egypt, which is in Africa, Djibouti in Africa, Cyprus, Europe, Azerbaijan in Far East, right? Not in Far East. So that is where the issue comes inside. But we have seen how to work with some of these things, and later we can actually map them. Well, right? That's the basic understanding behind this. So we have seen how to pick a data set from somewhere which doesn't have any label. We have seen how to apply KMeans clustering on them, and we have seen how to be able to build a simple map, plot them in a very nice way, right? And then overlap them with our continents, right? Very, very nice. So some of these things clusters are not right because of the scaling. But what will happen if we scale them, right? Is it possible for us to scale them? We can actually scale them and try and see as a task, so that we get them in the right place, right? So you can actually do that. So let's do something simple and let's see whether it's going to give us a better result. So we just try and see how to scale them simply, then move on to this one, right? Before we move on to this one, so let's try something simple. This is a crash course here, doing everything from scratch. So let's see how to scale them and see the result, right? You scale them, you're using min mass scaler. You can use several, this is different ways you can scale them, right? Which is part of feature scaling. You can have normalization, you can have standardization, right? So let's see how to use a standard scaler to help us with that. So it's going to be from sklearn dot pre-processing import standard scaler, right? Then you use standard scaler to help us scale it. So let's call it as our scaled. So let's call it as feature scaled. You can just give it any name, but something to make it easy. So let's call it as S scaled. which in this case is going to be for only our features, right? So it's going to be standard scalar. Then I'll pass in my stuff. So standard scalar dot fit transform. I'll pass in my S features. Apologies for the noise you are hearing behind. Now if I go back and I check what you have done so far, so this has been scaled well, at least it's better. Then we can actually work on it well, so we can actually try it out. So let's check it out. So in that case, we realize that we had this S features, right? This S features give us as longitude and latitude. We should not forget that longitude first, latitude first. We can actually move straight away and then use KMeans to help us with that. So let's call that one as the second KMeans. So we can just call it as KM2. So KM2. Then I'll just pass in my KMeans, right? Then I'll pass in my number of clusters. In this case, it's going to be 7, as we already know. Then I'll just create our new clusters, which is going to be our KM2 dot fit predict. Now pass in my S scaled. Now we can actually plot them. So let's go back to the same thing that we have done. The same thing that we did here. So I'll be picking this one is the same thing, right? So I'll pick the same thing that we did to help us with that, right? So let's make it like this. So what I'll do is that just as we did the data frame, I'm going to create another data frame like the previous one we did and then map them together, right? So let's do it like this option. It's taking time, but at least we will learn something from it. So df scaled to be df, right? Oh, let's make it like this. Yeah, scaled. And then we had these are our features that were scaled to df scaled. Got it. Clusters. Hopefully it works. New clusters. Yeah, it worked, right? So perfect. So we can actually come back here, df scaled. Perfect. So this is the new cluster that we have, right? So these are the new clusters, and now this is 3. This is United Arab Emirates, and then Afghanistan are all 1 right? So now it has scaled it in a better format. So the old one was 6 here, but the new one is 3, right? So that means that it has given us a better result, right? At least it's given us a better result. So we can actually plot them. So we'll be using the new scaled clusters to help us with that, right? Or we can even use the same that we have done and then plot them, right? It's still going to work anyway, right? In that case, we're not be using this one as our continent, we'll be using this one. So we can actually plot this stuff that we have done. So yeah, so that is it, right? So this is using the new cluster that you created, right? Not the old one, the new cluster. So this is giving us a totally different cluster. But the best way to do this is I can actually create a new data frame with the scaled latitude, longitude. Then I'm going to do the same, something similar to this. So let's do that. So let me make it simple. So I'll copy the code and paste it here, right? So something simple like that. So this is what we're trying to use. And then now let's check it back again. So new df.head. Right, so we the one that we scaled, the scaled data to build a new data frame, and then we use an old name and then a new clusters to build it in this particular format. So we can actually plot this one out. So I've already plotted it with this option. So let's plot it out. So I'm using the new clustering to plot it out. Perfect, right? So we can actually map them to it. So we can come back to the same thing that we did above here, this particular place right here, this stuff that we did. But let's copy this one first. Let's do this one first. Copy this, and then I'll copy this one. So that we save ourselves time and move on to the next session. So I'll copy this one too. So this is going to be data frame 2. Then we are using the new one that we created, right? And then we are the same thing. So I'll change this one to new, because it's almost the same thing, but now we are using the scaled one, right? I don't know whether we can even scale we can even scale latitude, but I think we can do that for this tutorial. So let me copy this one and then let's paste it and see, right? So that at least we are going to get almost something similar or something better to help us with our tasks. Let's come back here, then we'll check it out. So in case you're not subscribed to this channel, you can also subscribe and then check the links below for more. So this, we run this one first, putting everything in the right format. Then now let's do our plot. Perfect. See how all of the plots came to one particular point, because we scaled it with a standard scaler. So, and then remember that standard scaler is going to be from -1 to +1. That's why all of them are grouped here, which is a bad thing that we did. That means that the scaling did not work. You should have used a better scaler, right? So that we would have gotten a better result. But even if we go back and I use the old format, right, the old data set, I'm sure that at least it will be able to work very well, right? So in that case, I can just do this option, use the same thing that we did above, the previous one we did, not the scaled one, the previous one. So this one give us something bad. See that sometimes everybody also make mistakes. So you should have used min max scaler instead of using standard scaler. And even that, in that case, let's move on. Let's try it and see. And let's use the normal cluster to see what is going to help us with that. Okay, this is better, right? So this is better, right? This was almost the same as we did above, but in this case we are using the cluster, the new cluster that we did, and it's able to group them well, at least in a better way than the previous one. Now some of them are even in the islands. That is how to use simple KMeans clustering to help us to be able to segment or group countries into their respective continent, right? So you have seen how to do this simple task. You have seen how to use it to label it. So that's going to be an assignment for you. So the basic understanding is that you just have to work on it, and then later on you use this format that we're doing to help us with that, right? Then later you map them perfectly. So let's move on to the next task in the next session. So we're trying to see how to find the optimal k, right? So one of the ways of finding the optimal k, because we already know that there are 7 continents, we were able to just assume and then give a k of 7. But there are several ways that, in case you don't know the k, you can use elbow method or silhouette method to help you with that. Then how do you choose them? So we'll be trying to see how to work with them, but in this case we'll be using a different data set, right? So let's use a different data set, the customer segmentation. So we'll be trying to do our task 2. So let's put something here for our task 2. So it's going to be task 2, right? So in task 2 we'll be trying to do customer segmentation, right? That's what we're trying to do. So we have some data sets, we want to segment them into their respective customers. So this is what we're trying to do. So let's check it out. Then later we try and see how to use the KMeans to help us find it. So let's call that on my df, right? So let's call it dfj or dfc, anyhow you want it to be. Customer is going to pd.read_csv. They are using the jewelry data, right? That's what you're trying to use. I'm going to read it now. I can just go with df customer.head, which is going to give us these particular stuff. So we have age, income, spending score, and then savings. So these are the data that we have. we have their ages, we have their income, we have their spending score, we have their savings. So we want to be using KMeans or any of the unsupervised machine learning algorithms to be able to help us to find patterns within them and then group them according to their levels, right? To find the segments of customers, the different type of customers we have within our data set, right? Based on these parameters that we have. So as we have been doing always, we can just check for the d types, df.d types. We'll be skipping most of these things, but we just want to see how it is. Perfect. And then we can just do a simple descriptive analysis. Right. So we'll do simple descriptive stats. Let me change the theme to a white theme for now. So it's going to change it. Right, perfect. So let's see what we're doing. So I'll just come back to this simply that we have been doing. It's going to be df customer, right, dot describe. Perfect. So the mean age is 59 and the minimum age is 17, right? So that's what we have. So we have understood that our customers are between the age of 17 and then 59. That is the big idea. These are their income, their spending, and their saving. So we can actually do a simple scatter plot to just get an idea of the different categories within them, the different clusters within them. So in that case, it's going to be like this. It's going to be a simple plot. So in that case, we'll be just checking using the age and then the income, right? So using the age and the income, what is going to be the different clusters that we have? So it's going to be this option. So plt.scatter. Then I'll pass in my df customer. Then let's use the age. Then try the same one for df customer, which is going to be the income, right? So let's check it out. Perfect. So you can see that we have about 4 different clusters there. So we have these different clusters there, right? So that is something simple that have helped us to know using just the age and the income. We can actually do a group by to group them based on the age and the income to get the count of people within them. So something like df customer dot. Right, so we can do that one. So let's try it out. So we want to see the groups based on the age and the groups based on age and then income, right? So in that case, it's going to be, I've seen from the visualization that we have 4, but we can also sector them all. So it's going to be like df customer, then dot group by, we're grouping by the age and then the income. We want to get all the counts, right? Dot size. So if I check it now, you can see that based on the age, so people who are under 17, this is the number of people that are there, right? Then 18, then 94, and the rest, right? Something very simple, something very interesting. Now let's move on to our KMeans clustering, right? So how do we sort them? How do we group them? We have known from here that we have like 1, 2, 3, 4 clusters, right? But to be able to identify the actual clusters, we can use the KMeans algorithm to help us with that. So now let's see how to do that. So we'll not be, in this case, we'll not be assuming, right? Rather, you try and see how to find the optimal k number. So we'll be using this option. So in finding the optimal k number, we have 2. We have the elbow method, right? Which is like an elbow. So we'll be checking out where you meet the elbow. The point you're going to meet the elbow is where is the optimal k, right? You can also have the silhouette method, not silhouette, like silhouette method. So we'll be trying to see how to work with it. So let's check it out. So for the silhouette method, let's take off this. So for the elbow method, this is a simple formula. So you're going to get the sum of square distance as a variable, right, as a list. Then I'm going to create a range of all the number from 1k, 1 cluster, 2 cluster, 3 cluster, up to the cluster that you want. Then I'm going to loop through them and then build a model, right, and then pass it through them. You're going to find the best option, right? That's the big understanding. So you're going to run it. It's giving us an error. So the reason it's giving us an error is that we have to go with my customer, right? going to analyze it perfectly for us, and then from here we can actually plot them, right, in a very nice way, and in that case you'll be able to see it all. Right, so let's do our plot. So it's going to be our plot for elbow method. So we have already stored them inside the sum of square distance, so we'll be using that one to help us with that. So plt dot plot my k range that I had, and I pass in my sum of square distance, this particular sum of square distance that we have. Right, that is all. Right, so you can actually plot this one, but let's make it better. So plt dot my s label. My s label is going to be the number of k, which is k, right, which is the clusters. And then see how I spelled label. Lovely. So it's supposed to be this option. So that is going to be the k, and then my plt dot y label here is going to be, let's give it as my sum squared distance, right? Then I can also go straight away to the normal plot. I can just give it a normal plot. So this is going to be an elbow plot for optimal k, right? So let's change this one. And then also go back straight away to the last one. So plt dot show. We can now plot it. Going to give us a very nice plot. So you see that you can see from our plot here that we have this particular value. So these are our k clusters, and then our sum of square distance. So based on what we have done so far, you can realize that here, right, it's okay. There's a little bit bent here, but the elbow can be found here, right? There's another elbow here. So between 2 and 4, there's a simple elbow here. Then around this place too, there's also an elbow. So the best way is that you choose either 2 or 4 and check it out, right? Or you can use the silhouette course to help you with that. So let's go straight away with the 4, right? So we have seen how to get your optimal k. So if I go with 4, it's going to give us 4 classes. Even as you could see from the image here, that give us 4 different groups, right? So that means that if I choose 4, it's going to be good for us. So that is how to find the optimal k using the elbow method. But this may take time, right? In case your data is long, it may take time. So the next method is to use the silhouette method. Even in this one, you are actually guessing, right? You are using this one here to in between 2 and 4, and then even 4 itself. So this is even like a guess. It's okay, but it's not very, it's useful, but you can also do better. So in that case, we'll be using the silhouette score method. So for the silhouette score method, you are trying to understand 3 different things. If the silhouette score is close to 1, it means that the data point is inside its own cluster, right? And if it's 0, that means that it's close to the boundary. Then if it's negative, that means that it's in a different cluster. It's in a wrong cluster. So in that case, I can just come back to the same place here, and let's check it out. So there's a method for silhouette method. So I've already typed it to save us time because it seems here talking a lot. Okay, so I can just come back here and let's make some simple modification using the same thing that we did. Class customer, this is going to be for our customer, right? And I'm going to run it and see, right? So if I run it, it's giving us a named error. The reason it's giving us this named error is that we can check it out. Silhouette score is not defined, so let's import it first. So I'll just import it here. So this is going to be from scikit-learn .metrics import silhouette score. So that's what you're trying to import, right? We have silhouette sample. We also have silhouette score, right? So we're using the 2 of them to help us with that. Then I'll run it again. It's giving us another error. So let's check the error out. Could not convert string to float. So the reason it's giving us this error is that we are supposed to get some things out, right? So let's face it out. So let's make it. That's the disadvantage of copy and paste, right? So perfect. So it's giving us the number of clusters. So we want to calculate which of them is the optimal K, right? So if the cluster is 2, this is the Silhouette score, right? And as we learned earlier on, if the score is closer to 1, right? We learned earlier on, if it's closer to 1, that means that the points are within their own clusters. If it is 0, that means it's close to the boundary. If it is -1, that means that it is in the wrong cluster, right? So based on what we are looking at here, you can see that from here, the best one we have 6, right? The best one here is 5. 5 is 6.7, 6 is 6.0, but the highest of them all is 4. 4 is 7.2, right? So that means that either we choose 3 or 4, not 2, not 5 or 6. So the best cluster to use here in this case is that we can either choose 3 or 4, which is almost similar to the elbow plot. So the elbow plot give us something like here. So in between 2 and 4 there is 3, and then also at 4 here, right? So that is the best way we can actually cluster them. So with the elbow plot you can see it visually, right? With the Silhouette score you can actually predict and see which of them is the best. So we're going to loop through them based on the number of clusters you specify. Then it's going to build models using K-means, and then going to find the best score together with the best score. So the higher the number and how close the number is to 1, that means that is better, right? And you also have to work on it. So this and this, so you can either use 3 or 4. You can actually plot them out too. Perfect. So we have been able to see how to get it. So as I was talking about the Silhouette plot, you can also do that. But before we move on to the Silhouette plot, let's first of all use what you have understood. So you have understood that we need the number of clusters that we need is 4, right? Or 3. And then using the Silhouette score, we have been able to see that the best option is either 3 or 4. So we'll be choosing 4. So let's use it to do our simple clustering. Then later on we'll plot our clusters. So in that case, it's going to be like this, as we did above. So this is going to be we will initialize our model. So as we did above, we are just going to use the same option. So let's call it as KM model 3, or we can just give it any name that we want to be. So we can call it KM3, right? For KM model. Then we can just give it the same thing. So KMeans KMeans. Now passing my number of clusters. We are using based on the Silhouette score. The best is either choose 3 or to choose 4. So let's use 4, right? So I'll go with 4. Going to analyze it. We're going to initialize our model. Then it's giving us an error because I'm sure we made a mistake somewhere. N cluster. It's supposed to be N clusters, not N cluster. Okay, perfect. So from that we can actually do the same thing that we have been doing over and over again. Fit and predict them. So this is going to be our fit predict. So let's call it as my Y predict for the Y prediction, which is going to be my KM3 dot fit predict. Now passing my data for this one, right? Going to analyze it and then give us the right prediction. Now these are the different classes that we have, right? You can call it Y predict, you can call it Y class, anyhow you want it to be. And then these are, so we have 2, 1, 3, and then 0. That means that there are 4 classes. So we can actually plot this one out. So let's see how to do that. So let's see how to do that. You can actually even check for the number of clusters, right, that we have, which you already know that is 4. We can also check for the centroid or the cluster centers for this first cluster, which is going to be the same thing. So KM3, right, dot cluster centers. It's going to give us all the various cluster centers there for this particular cluster that we have. Very nice. And now let's do our simple plot. So to do our simple plot, I'm just going to go back to the same thing that we had. Just this our data set. I'm going to push the various classes on it, right? So in that case, I'll be putting it beside it. So it's going to be something like this. So df customer, my clusters. Let's go to my Y predict. We can call it as Y class. Perfect. So if I go back and I check it again, now they are in the right classes, right? The right clusters. Very interesting, very nice. And now we can actually plot them out. Right, so let's fix that one also. I'm just going to do our first plot, but before we plot them, let's put them in a simple format, right? In a different data frame. So if I go back with df.customer.cluster .unique, I hope it was called cluster. Let's check and see before we make a mistake. Clusters, right? Yeah. If I check it, we have 4, right? So I can create 4 different data frames. So let's call it df01, which is going to be my df customer. I'm going to pick a particular variable, then check and see that, and group only the 1s together, only the 2s together, only the 3s, and then 4s. Then do a scatter plot for them. So it's going to be this option, df cast. Then here is going to be my clusters. So clusters is equal to 0. That's the first one, right? So if I go with this option, it's going to group only that one for us, right? Only clusters that are 1. Then I can also try it for the next one. Let's copy this one. Try it for this, for this, for this. So how many do we have? 1, 2, 3, 4, right? So now I'll just change this one. This one. This one. So I'm changing this one. So it's going to be 1. It's going to be 2. It's going to be 3. Then 3. I'll come back to this place. Change this one to 3, 2, 1. Right. So this is going to be 1. Let's make this one 0. Right. 0, 0. Something simple. Right. To make it interesting. Or can even make it like 0, 1, 2, 3. Perfect. Right. So this is better. Right, so let's go with this option. Perfect. Now we can actually plot it out. So let's do a simple scatter plot before we do another scatter plot for the centroid. So in that case, it's going to be like this. Of clusters. This has been a very long tutorial, so it's going to be this option. So plot.scatter. Then I'll be, just as we did above, we just pick the first value. So df1, I'm just going to go with my age, and then you can also do the same thing for the income, right? Or the savings. You can just use income, you can use savings anyhow you want it to be. So, but let's use savings for now. And I'll specify a color. So let's give a color, let's say this one is going to be blue, right? Something like that. That is all. So if I run this one like that, this simple stuff, it's going to cluster it perfectly for us. So this is how it looks like, right? Very interesting and very funny plot. But we want to group them more, so I can now do the rest. So copy this one here, and I'll correct them. So 1, 2, 3, 4, 5. I'm going to change them. Right, perfect. So I've modified them. Now I can just give it a label. So plot.slabel, which the labels are going to be the features, and then plot.ylabel going to be the cluster that we have, right? So this is one way of doing it, and then I can just go straight away with this. So let's go with plot.show, or we can just go straight away with this. It's going to still plot it anyway. So that's cluster is in a very nice format for us. So we see that we have our green, right? Our green, our yellow, red, and then there's a mixtures here, right? Because we are clustering them with 4 different clusters. Very interesting. We can actually even add a legend to it. So let's see how to also do a cluster, right? A simple plot, but showing the centroid. So that is something simple. So that is, we already learned that for the clusters we had it like this. 3 dot cluster, this one, right? So these particular values, will be adding these particular values into our plot that is going to show the particular centroid. Then we will see the scatter plot around it. So let's check it out. So this is, I've already written it to save time, so it's almost the same thing. And let's change this one to make this one black, and then let's check it out. So the same thing we are doing, but in this case we are bringing the model that we had, which in this our case it was K3 model, right? Our clusters underscore centers, then you'll be picking the first one as we did above. Then let's plot it out. It's giving us an error because we have missed something. I'm making a lot of mistakes today. Okay, so let's check it out. Voila, so just finished giving us a very nice plot. So you see that we can have our centroid. So the centroid, they are the plus, right? Very interesting and very funny plots, but at least we understand the concept behind it. So that is how to work with KMeans clustering, how to do a simple scatter plot. So we're able to cluster our data set, cluster our customers. So now we know that we have 4 different customers, and then all of them are clustered around these ones, right? So here there's one here, there's one here, but this is not properly clustered. So the next solution to this is to scale them. So if you scale them, it's going to be better, right? So we'll try and see how to do scaling. But let's move on to the next one, using the Silhouette plot to help us do another plot to know the best score, right? The number of clusters. So I've already written the code to save us time. So the Silhouette score, as we learned earlier on, is to help us to know which is the optimal K, right? We can also do a Silhouette plot. So let's see how to do that. So I've written the code, hopefully it works. So don't worry about it, it's going to be below so that I can also work it out, check it out. So let's run it. And then now let's see how to do the simple plot for that. So the basic way, based on how the plots, the function is that it's going to take your data frame, right? And then that is your features, then your predicted labels, and the number of clusters you want to cluster, right? That's the basic understanding. So I can just copy this one, or just go straight away to this. So there are a lot of things you're supposed to do. Anyway, you move on. So this is going to be my Silhouette plot, right? So it's going to be my Silhouette. I'm going to pass in what I'm passing in as my data frame that I have. So in this case we had it as ef.cost, the customers. Then I'll pass in the next one, which is going to be my y predict for the clusters. Then I can just go with my number. So in case I want to check for 4 whether it's going to work, so if I go with 4, then I can just go with that. Oh, that is the only thing I need. So let's set the axis is equal to none. So let's plot and see. Hopefully give us a perfect plot. Perfect. So this is how it looks like, right? So this, in case it is 4, and how do we read this particular plot? How do you read it? So the simplest way of reading this Silhouette plot is this. You are using this particular line, this average line, right? Anything that is exceeding if, and then you are using these ones too. So you are using the thickness of these particular silhouettes to determine how much of your data points are in each particular cluster, right? So that is if it is 4, right? So this is almost proportional, but this is too small, right? For cluster 2, it is very small. For cluster 3, this amount, and then cluster 4, so almost the same thing. That is the first thing. And again, you're not only just checking the size or the thickness of the silhouette, you're also checking if it reaches this particular average line, right? This particular score. So if it extends here, that means that it is almost good, right? So you can see that most of these silhouettes, this one, and then almost this one stops at the end of this red line. That means that it's almost good. But let's try a different one. Let's try a different number of clusters. So I'll just copy the same thing and then try a different number of cluster. Then we'll explain it again so that you get it better. So just come back to the same place. Then let's change the cluster from 4 to 3, right? So I check it out, run it perfectly. So looking at it, if you use 3, you can see that the thickness are almost the same, but this one is too small. And then most of these ones, they exceed this red line, but this one doesn't reach. So that means that it's good, but it's not that good. Let's try it with 2. Try it with 2. And we can try it with 6 or any of them. So let's go back to this one. So let's go with 2. And you see how it is, right? So one of them does not even reach, and this one, the thickness of it is too big. Because one of the thickness is too big, it's not a good cluster. You can't use 2. This one is also okay, but one of them is too small. This is better, right? At least almost proportional, but you see the line. If I make it more than this particular value, you can also see that. So if I go back to, let's choose something like, let's say a higher number like 6 or something. Hopefully it works. Right, it gave us, we chose 6, but because the limit is 4, that's why it's giving us this particular stuff. So that is how to do a simple silhouette plot to help you with your KMeans clustering. Very, very interesting, very, very nice, very, very cool. So you have seen how to pick a problem from scratch, and we have seen how to use KMeans on that particular problem to label this particular data into or group them based on their continent. You have seen how to use KMeans to also help us to segment our customers, and we have seen how to do LB scatter plots with Centroid, elbow plots to help us to check for the best K. We have seen how to use Silhouette score to help us get the best K. We have also seen how to do simple silhouette plot. Very nice and very cool. So in the next session, we'll be trying to see how to work with a different algorithm, right? So the DBSCAN algorithm. Alright, so welcome back again. So in this particular session, we'll be trying to see how to work with the DBSCAN, right? So the DBSCAN stands for density-based spatial clustering, right? Which is another way of clustering, which is usually based on densities, right? That's why it's called density-based. And then let's see how to work with it. So it refers to an unsupervised learning method that identifies distinctive groups or clusters in the data based on the idea that a cluster in data space is a contiguous region of high point density, right? That's the most important thing there. Separated from other clusters such by clusters by contiguous regions of low point density, which is very interesting. I got it from KD. Okay, you can read a lot about it, but let's move on first. So the usefulness is that can be used for outlier detection, noise detection, then can also be used for most of the unsupervised machine learning activities. So the basic term to understand with DBSCAN, density-based scan, is that you need to know something about the epsilon. So the epsilon is the distance measure that will be used to locate the point in the neighborhood of any point, right? Then we also have the minimum point. There's the minimum number of points that is supposed to be considered so that a particular group of data belong to one particular point, right? So that is something simple. So these are the formula to get it. So in calculating the minimum point, it's always supposed to be greater or equal to the dimensions of your data plus 1. That is the simplest formula to get it. Then also have the core point, which is the point that at least m point within the distance can be found. So let's see this plot. I think a lot of people have better explanation than what I'm doing. So this is how it is. So this is a simple picture to help us get it. So we have our core point, right, which is this particular one. We have our border point. Then you have our noise point. So as I said, we can use it to identify noise. So noise are people that are not found within, or data points that are not found within our core point, is not close to our core point, and not found within our boundary, right? That is the basic understanding behind them, right? So this is going to be our core point, our border point, right, and then our noise point that is far from the core and far from the border. Something very interesting, something very simple. So let's see some stuff. So in working with DBSCAN, it's very important that just like KMeans, you're supposed to always scale your data. So you scale our data, then you work on it very fast. So let's check it out. So this is going to be our stuff. So I'll just do the same thing that we did above, then we'll scale them, then move on straight. So it's going to be this option. So let's go as df for now, then pd.read_csv. Then we are using our jewels data. Perfect. Then from here, we just check for the shape of what we have. So we have 4, right? So 505 and then 4. Now let's see how to do that. So first of all, we're just going to preview what we have. Then we will scale them, right? So we're going to scale these ones to make it better. So we can use any of these scalars, min-max scalar or standard scalar, which is a standard scalar, and then min-max scalar is this is a normalizer, and this is a normalizer and this is a standardizer, right? Standardization, this is normalization, right? So let's check it out. So we'll scale our data. So going from scikit-learn preprocessing, import standard scalar. So I'm using standard scalar to help us with that. Then from here, we just take our data set that we had. So let's call it as S. Then I'll just pass in my standard scalar dot fit transform. supposed to do this option. It's a function class fit transform, and I pass in my df, right? Perfect. And from here we can do whatever we want to do. So let's give some space, and then now we can work on it. So if I go back to this same thing that I had and check it out, then that has been scaled in a better format, right? Perfect. Right, so this is now in a better format, so I can actually put this one again into a data frame and then work on it. But let's skip and then work on our model. So we initialize our model, which is going to be DBSCAN. So it's going to be from scikit-learn.cluster import DBSCAN. And make it bigger, and then we'll be using DBSCAN to help us with our stuff. So let's create our model. This is very long, right? So DB, let's call it DBSCAN. Then I'm just going to go DBSCAN, not DBSCAN model. Then I'm just going to go straight away with my DBSCAN. As we said earlier on, there are some important factors that we need, right? We need to be able to set the minimum point, right? And then the epsilon, which is very important. These are very essential. These are the parameters that you need to tune to make it be able to give us the best or accurate prediction, right? Or clustering. So can just go straight away with this. So let's go with an epsilon. So for the epsilon, we need to know the range, right, to help you. But there are a lot of tutorials around that explains it better than I'm doing. So minimum sample. So let's give it as a particular value. Let's give it 10, right? You can just give it any particular value, but let's give it 10. It's giving us an error because we made a mistake. It's supposed to be minimum samples. I don't know, now today I'm making a lot of mistakes. Right, perfect. Now let's move on straight away, and let's fit our model, right, to our data set. It's going to be my dbscan dot fit predict. I pass in my s features, right, the one that we scaled, this s. So s. So let's store this one as my y cluster dbs, right, for the dbscan. It analyzed it perfectly. So now everything is working. If I go back to the same thing that we did, so cluster dbs, now it's giving us 0101, right? This is a scaled data, right? Very interesting. So for the dbscan, it's very useful when you are working with either spherical data or non-spherical data. So but the data that we have here is non-spherical data, so the plot that you will be generating will be totally different. So let's try and see how to plot it out. So this is going to be my method. So let's count the number of unique clusters there that you have. So the simplest way of counting is going to be like create a set, then y cluster. We are using the y cluster stuff, yeah, right, to give us the number. So we have this one, so 0 1 2 3 so we have about 6 different clusters, right, from this particular range. And then we can actually do a simple plot. This is going to be a non-spherical spherical data. So in that case, it's going to be like this: plt.scatter. Then I'll pass in my particular stuff. So I'm using the first value because these are two different. It gives us as a numpy array. So I'm just taking the first one. If I put it inside the data frame, I could have used that particular one, but because I'm not putting it inside the data frame, we can just go straight away with this option. And this is going to be -1, right? No 1. Yep. Then here I can just give my colors. So the colors I'm using is going to be my y cluster dbs, right? Because these are numbers, it's automatically going to give us a plot. Hopefully it doesn't give us any error. So perfect. So let's see that it has been able to give us the same, almost similar cluster to the KMeans, because this is a non-spherical data, right? It gives us also almost the same thing. It gives us as at least 1 2 3 4 5, like almost. This is can be seen as one cluster, another cluster, almost about 4 clusters, right? Almost 4, but it can also be seen as 5 clusters, or yeah, something very simple, something very interesting. So the DBSCAN is also very useful, very nice and very cool. Now that is how to work with the DBSCAN. Let's see how to work with the hierarchical clustering. Then in the future we'll see some other stuff. But before we move on, remember that when we were talking about the DBSCAN, we also said that we can use the DBSCAN to help us identify noise, right? There was a noise point, so in case you also want to find a noise point within it, you can use the DBSCAN to help you count the number of noise within this particular data that we have, right, within this spot. So you can see that there are some that are going to be noise, so in case you want to count them, you can use DBSCAN. So let's check it out on how to do that. It's going to be, let's go to my labels. So this is going to be the number of clusters, right, in our stuff, number of clusters there. So it's going to be something like this. So labels, and I'll just go with my DBSCAN labels as we did above. This is supposed to be DBSCAN.labels. Perfect, right? Then I'll just go with my number of clusters. It's going to be the length. Then I'm going to get a dictionary, right, a set of my labels, right? Perfect, that is all, right? And I'm going to subtract it from, I'm going to ignore noise if there's present. So now we are counting the number of clusters within them, so be ignoring noise, right, if there is any. So it's going to be 1, right? So if -1 labels, else 0, right? So this is going to help us to ignore them. So hopefully it works, it doesn't give us any error. So invalid syntax, we had a mistake somewhere. Let's fix it out. If 1 in labels, right? Perfect. So I can check the number of clusters I have here now, and then we have about 5 clusters. So the best way to classify this one is not just with 4 clusters, right? So the best way from this data, so we have identified 5 different clusters. 1, 2, 3, 4, 5. Very interesting, right? Not like 4 as in the KMeans, right? Very interesting. Now let's check some other stuff you can also do in case I want to identify the noise. So to identify the noise, there's going to be identify noise. That's one of the features of, one of the usefulness of DBSCAN. So in that case, it can be something simple like this. So there's going to be n noise. Then I'll just go with my list. I'm going to get all my labels or clusters, right? That is something simple, and I'm going to count it -1. So dot count -1. So -1 is going to be the noise there, right? So if I go back and I do it n noise, so we have about 30. So we have about 30 different points that are actually noise, right, within a data set. And I think this may be the noise, right? So if we count them, that's something very simple, something very interesting, because they are not, as we said earlier on, a noise is one that is not found in a border and not close to the core point. So a noise is something here. So this is going to be a noise, right? So this is the boundary, this is the core point, right? But the noise will be far away from that. So in that case, it is not in the right location, right? And it is -1, right? As we learned earlier on, that -1 means that it is in a wrong cluster. So it is a noise, right? So that's why we use this option of count -1, right? So anything that is -1, we are taking it out, right? Because that is a noise, and we had about 30. Wow. So very interesting and very cool. So let's move on to the hierarchical clustering, then we move on to the BIRCH. So we're skipping the BIRCH for now, and then we move on to the hierarchical clustering, which is very common. So for the hierarchical clustering, as the name goes, hierarchy, right? So we are trying to build a hierarchy or ordering of the classes till we get only one cluster, right? So that's like we are building a hierarchy. So the first one is going to be, let's say, 5 clusters, 4, 3, 2, 1, right? So that is what you're trying to do. We are using that one to help us to cluster it. So the highest, from the highest number to the least, right? Then we are going to stop it. So it's very useful, and there are different types of hierarchical clustering. We can have the additive or divisive. So additive means that you are trying to, from the word additive or agglomerative. Agglomerate means to join or to merge, right? So we are trying to join them, right? And you're assigning each point to a cluster. The procedure is you are trying to, the main idea for the additive or agglomerative is that you are joining them. Then you are going to assign each point to a cluster, then going to join them, right? And you find those that are close to one another, then you repeat until you have a single cluster. So I think I had some images to show. So let's show the image. So it's going to be something like this, right? So first of all, you just have your data set, right? And every data point is now in its own cluster. So let's make it like this. Every data set is now in its own cluster, right? Then after that, you group them again, right? Then you're going to find the next cluster which is closer. Then you keep on joining them, right? Like that. So that is the basic understanding till you come to one, only one, right? That is the basic understanding. So you start from individual data point as clusters, then you find the nearest cluster. So for example, this is the individual clusters that we have, right? So this one, these are the individual clusters, then I'm going to build another cluster to the nearest one here, right? It's going to be this one, right? The first two here, this one, then we're going to move on to the one that are close together, which is also going to be another cluster. Then the one that is close together, which is going to be another cluster. So it's like a hierarchy of clusters you are putting until you get your final cluster as one, right? Something like that. That's the basic understanding behind hierarchical clustering. So let's see, there's also another option of divisive, which is the opposite, right? You start from the larger, then you break it down. You split till you break it down till you get to the individual single data point. So some basic terms to understand is that this one has to do with similarity distance. So you start from individual data point, you group them into clusters. The clusters that are close together become one cluster, then you move on to the next, right? Then there's also probability matrix, which stores the distance between each point. So be measuring them. If they are close, that means that they belong to a particular cluster. Then the best way to find the number of clusters is to use Dendogram for this particular option. So we're trying to see how to work with a Dendogram. So simply put, Dendogram is a tree-like diagram that records the sequence of merges or splits, right? So let's see how to work with it. So I'll just come back to this. This is going to be the last tutorial because we are taking a lot of time. Hope you're enjoying this. Hope I was not talking too fast. So let's do the same thing that we with the Geos dataset. So we're going to load our dataset, right? And then we work on it. So in that case, it's going to be the df as we did pd.read and also csv, our Geos dataset. That's what we'll be using still for customer segmentation. Then from here, we can do another stuff. So from here, what we'll be doing is that we'll be trying to, first of all, we must scale our data as we did above. But this time, we'll not be using the normal standard scaler. We'll not be using standardization, we'll be using normalization, right? So we're going to normalize this data set. So let's check it out. So I'll be using, we're going to be from scikit-learn pre-processing. We're going to import normalizer, right, to help us with that, right? Normalizer. So importing normalizer. It's supposed to be normalizer, right? Normalize. See the mistake I made, that's why it's not working. Import. Perfect, right? So that's what you're trying to use to scale our data for now. So let's scale our data, or normalize rather. It's still the same thing. It's part of feature scaling. Then we have our data frame. So let's call it df.scaled. Then here I'll just pass in my normalize. Because all of them are numbers, it will be able to scale perfectly for us. Perfect. And I can also convert this entire stuff. So if I check this one now, this is going to be in NumPy numbers, right? NumPy array. But I have to convert this one into a data frame. So let's go pd.data frame. And I pass my df scaled. Then from here I'll just go with the columns. I'll use a column that we used previous time, df.columns, right, for our data that we loaded. So now it's better if I go with this. Everything is working as expected, right? So it's perfect. So now it has been scaled as compared to the previous one. So if you check this one, 58, but now this has been scaled well, right? So this is a normalizer, so it's scaling them within a particular range, right? So that's why even the number has reduced, right? So between 1, within a range of 1, right? Very interesting. So let's check out how to use hierarchical clustering. So as we learned earlier on, to identify the number of clusters that you need, there are 3 methods. You can use the elbow method, you can use the silhouette method, mostly for the KMeans, but for the hierarchical clustering, you can use the Dendogram, right, to help us know or detect the number of clusters to use. So let's see how to do that. So I'm going to be using SciPy to help us with that. So it's going to be detecting number of clusters, right, using Dendogram. So it's going to be like this. So let's import SciPy. So import SciPy dot clustering cluster dot hierarchical, import SciPy dot clustering dot hierarchical as SHC, right? SciPy. Then we will use this one to help us plot. So let's create a simple plot. plot.figure, then figure size is equal to, this may be a very long tutorial, apologies for that. I can also give it a title. So Dendogram for customers, right? Something like that. For Unsupervised Machine Learning, right? Something like that. Then I'll just work on it. So it's going to be my then S SciPy hierarchical clustering dot Dendogram, right? Then I'll pass in 3 parameters. So first of all, I'm going to go with sc dot linkage. Then I'll pass in my scaled data. That's the first parameter, which is going to take a method. So the method I'm using is the word method, right? Perfect. So let's check it out. It's going to plot it perfectly for us. So in understanding the Dendogram, it is very simple. I want it to generate, then we will use it to explain it very well for everybody to understand. Perfect. So that's finished, right? So this is how it works, right? So the Dendogram, as we are learning, we are trying to work with splitting. So first of all, it's like splitting like a hierarchy. So this here, you're going to split them one after the other, right? And then find the most closest, then join, find the closest, join, like that, as we were seeing in this particular picture here. So it started with this. So individual, that is, let me make it like this. Let me take myself off, right? So something like this. So first of all, it's going to start. You see that this small stuff that we can see here, these small 111, right? So they are the individual data points. Then it's going to find the one that are closer to one another, which is going to be the next one, which is going to be these 2 lines here, right? So that is those that are close to one another. Then to another one, expand the scope, which is going to be the next one, which is this particular one here. Then like that till it finds 1, right? So that is the beginning. So it's going to start from here, the individual small ones that you are seeing here, 1, 2, 3, these small ones. Then it's going to build another cluster, then join them together, right? It's going to be that line that goes like this. Then the next one, repeat the same stuff till it becomes 1, right? So that is a big understanding to where it reach. So the highest point you are going to reach, the minimum level you're going to reach, is going to be your threshold, right? Then that's the number of clusters you're supposed to use. So in this place, it started from here, but we can still go further, right? And then when we went further, we had it at this particular place. So you can actually plot that particular line. So let's plot it out. So I'll copy this one here, and then we will plot it. So it's going to be like this, the same thing that we did, but now we're using plot dot line, right? Is H line, the H line, horizontal line, then we can specify the particular value I want it to be. So looking on this, right, we cannot put it here. I cannot put it here, right? Because there are a lot of lines. I can still go further. I can't put it here because I can still go further. I can put it here. I can put that 2, right? If I put that the first one 2 here, if I go further, there's nothing more. There's no more there. There's nothing there again. So that means I can put that 2. That means that the number of clusters for this particular one is mostly 2, or we can even say 4, but let's make it like 2, right? So I can put this particular line as 2 here. That's the Y. Then I'll just give it a color. So let's give the color, let's say R for red. Then I can just give it a line style. So in this case, the line style can be, let's give it as a dash dash. So if I plot it, now it's going to plot it and then put that particular line there for us at the point of 2, right? Because 2 is almost the one closer to this place. That is, after that, there's nothing more. There's no branching. There's no splitting again. Take some time for it to run. It's going to give us our plot. Perfect. So that's finished, right? And you can see the line there. So the lines are 2. That means that is good, right? So we can use 2 to help us with our number of clustering. So that is how to use the Dendogram to identify the number of clusters to use, right? So we already had 2 here. We can actually make it 4, which is going to be here, but it's not the best, right? So 2 is better, right? So let's check it out because we have only 2 lines, one here, if it as the least final. So let's see how to build our model and then plot it, right? So this is going to be something very simple. Then move on. So it's going to be our model building. So we are using the agglomerative or additive format of hierarchical clustering. It's going to be from scikit-learn.cluster import agglomerative clustering. Perfect. And because we have already scaled our data, we just go straight away with our H cluster. Then we just go with my agglomerative. Then I'm going to give it my number of clusters. So the number of clusters that we can use is, you can use 2, right, for this one. You can also use 4, but let's use 2. And then you can also move on to set the linkage as we did for the Dendogram. And you can also specify the particular affinity using the Euclidean affinity using the Euclidean, right? Euclidean. It's going to be Euclidean, right? I don't know whether the spelling is correct. Yeah, Euclidean. Then we're going to specify the linkage that we use for as word. So we're going to initialize it firstly. Then from here we're going to build it, right? So go response Y cluster HCL. Then from here I can just go with the H clusters dot fit predict. Now passing my scale data, right? Predict my scaled data, which was df scaled, which was this particular scale data we used initially. This one here, right? That's what we are trying to do. So after that, I'll just check for our predictions, making sure that everything is working as expected. ACL. So we are using the same data set, so it gives us 1 0, right? 1 0 1 0 for most of them. Very interesting. Now we can actually plot this one out. So let's do a simple plot. So it's going to be our plot. It's going to be my plot.figure size. So in case you have any question or contribution, you can just put inside the comment section below, and then please don't forget to subscribe and click on the notification button so that anytime there is a new video, you'll be able to have access to it. plot.scatter. This has been a very long tutorial. And I'll just go with the age, right? The next one is going to be the income. remember that we place it back again into data frame. Scaled. Using the income, you can use the savings anyhow you want it to be. Let's use the savings. Then now we can just see the C for the particular stuff. So before we put on the C, let's equate it to our stuff. It's going to be my df scaled. It's going to be y predict, or we call it as y class. Y cluster ACL, right? That is the name that we give here, right? Y cluster ACL. Then you try that one out. So it's giving us, it's supposed to be HCL. Perfect. So we can actually use that one for our color mapping, right? So we can use that one, or we can use the labels from the class to help us with that. So it's going to be my df scaled y. Oh, we see we made a mistake somewhere. We have made a mistake here, right? So because we have made a mistake, it's going to give us an error. So let's come back to this place and initialize everything. So just initialize it here, normalize them, scale it. Otherwise it's going to give us an error. It's an error. Okay, so let's come back here and let's make it like this. Yeah, right, so this is better. So from here I can now do it this option. So let's check it out and see. Perfect. So this is a clustering that is given to us, right? So it is very interesting clustering, right? This is a different clustering from the previous one we have done. That is how to do simple unsupervised machine learning using Python, using scikit-learn. So we have seen how to use 3 different methods. We have seen how to use KMeans. You have seen how to use hierarchical clustering. You have seen how to use do plot for elbow plot, silhouette plot, Dendogram. You have seen how to use supervised machine learning to label some stuff. We have seen most of them. The only one that is left for us to do is the BIRCH, right? So the BIRCH stands for balanced, iterating, reducing, and clustering using hierarchies, which is really useful when your data is very large, right? It's just like KMeans, but it's useful when your data set is very large. So let's try that one out. Very simple. It's very simple. I'll copy the code and paste it to make it faster for us. Otherwise, we take a lot of time. So let's check it out. Right, so let's see how it is. So we're just going to import BIRCH from cluster, from scikit-learn.cluster. Then going to build our model. So in working with BIRCH, you need to know the branching factor and then the threshold, right? So the branching factor defines the number of subclusters that you need. Then the threshold is going to set the limit between the sample and the subcluster, right? There's a big understanding behind it. So using our same data that we have, going to build it perfectly for us. Then just as we have been doing, we have fit them together, we can actually predict, or just do fit predict like we have been doing always. Then now let's see our simple plot. It's also going to be similar to the KMeans, right? Almost similar, right? Almost the same thing. But the advantage of the BIRCH is that it's very useful and memory efficient and very useful when you're working with large data sets. So that is the big understanding behind unsupervised machine learning. I hope you have learned a lot. We have talked so much. I don't know how many hours you have spent. But thank you for watching this long tutorial. In case you have any question or contribution, you can just put inside the comment section below, and then the code will be below together with the links below. So thank you for watching. Thank you for spending time with me. See you another time. Thank you once more. Stay blessed.